This is the second webinar about ChemCurator. In my previous webinar, I gave you a brief introduction of the main functionality of our new chemical information extraction tool, the ChemCurator. Today, I want to show you a little bit different. We continue the development since the last webinar, and based on the first user feedbacks and evaluators feedbacks, we implemented long list of new features and improvements. But today, I don't want to go through these new features. I want to show you a full curation process. I think it can be more relevant for you in your daily work. First of all, if you start the ChemCurator, this is the first screen you can see, and you need to make your first decision what kind of data source you want to use as a starting point. ChemCurator supports a lot of different kind of data source. You can use HTML, XML documents, character-based PDF documents, or scanned PDF. We support all these formats, but that not means you can reach the same quality using all of these formats. If you use some high-quality input format, for example, Google Patents XML, or if you have access to IFI claims, XML document from IFI, or a high-quality PDF, you can reach better quality result compared to the manually scanned low-quality PDF document. In this presentation, I want to show you a curation based on a Google Patents document because this is available for everybody. The first thing you need to do to create a new project, you can use this plus button and choose import document from Google Patents. You can use the example patent number, or you can type anything else, any other patent number or word here. For example, if you type aspirin, the tool automatically searching all relevant patents, but I don't want to use that. You can do the same by double-clicking to this example, and it appears here, and you can import it. Click on Finish, and based on your annotation settings, the annotation is started. You can see the progress here. Depending on the size of the document, it takes 1 or 2 minutes. If you use some PDF documents, mainly in the case of scanned PDF, it can take more time. And the result is depending on what kind of third-party tools do you have. For example, if you have an installed optical structure recognition tool like OSRA or Clyde, the ChemCurator automatically uses these tools to recognize image-based information in your document, but you need to separately install this kind of tools to be usable in ChemCurator. As you can see, the annotation is finished and the document is opening. It takes some seconds. As you can see in the Project Explorer, a new project appeared here. And currently there is nothing under it. Here you can see the document. It's absolutely the same format that you can find in Google Patents if you search the same publication number. As you can see, all of the chemical information is highlighted in the document, and image-based information based on a Clyde recognition also highlighted because I have an installed Clyde in my machine. You can use ChemCurator in 2 main extraction modes. We called one of them compound extraction, and we called the other Markush extraction. The most typical and most general use case, the extraction of simple compounds. If you want to extract simple compounds from the documents, you need to create a new compounds list. You can give any name you want. I think compounds is absolutely perfect now. And as you can see, a new empty compound list appeared next to the document. If you select any annotated structure from the document by clicking on it, you are able to drag and drop it from the selection list to the structure list, and it appears here. You can see not only the structure, but also the formula, molecular mass, and the UPAC name of the structure. You are able to select multiple structures in the same time if you want. For example, going a little bit lower, you have two structures here. You can drag and drop in the same way to the list. This is one way to extracting simple compounds, but this is not the most comfortable. Yeah, I forgot to mention, if I click any of this structure, the tool is automatically scrolling to the relevant part of the document and highlight you. This way, you can very easily check anytime what was the context of the extracted structure in the original document. Let's delete these structures. And I want to show you the recommended way to extracting larger number of structures from the document. You can use the extraction wizard here. In the first page of the extraction wizard, you can set some very simple molar mass criteria, eliminating some low molecular weight compound what is not necessary for you. And if you have some special interest, what kind of structures do you want to see, you can use some kind of substructure filter. Let's give some variability to this filter. For example, adding it can be any bond, and this 3 atom can be a list of carbon, nitrogen, oxygen, and sulfur. This way, we can find all of the structures from the document matching to this substructure query. Let's run it. And as you can see, the application very quickly extracted all the structures from the document matching to your criteria. If you click any of them, the tool automatically scrolling to the first occurrence of this molecule in the document. This way, you can very easily capable to extract large set of compounds, and by automatic scrolling function, you can go through the extracted structures and check this is relevant or not, and if it's not, you can simply delete any of them or add something not recognized, and so on. That was the easy part. Some of the users don't want to do anything else, but others want to extract the Markush structures from mainly for patent documents. This is a little bit harder. Usually the claim section of the patent described by some Markush structure. If you want to extract Markush structure, the first thing what you need to do to create a new Markush structure. The same way what I mentioned before, you can give any name for that. Markush is perfect. And as you can see, a new empty Markush structure appeared here. If you click on the scaffold and it's recognized by an optical structure recognition tool, it appears under the document in the selection view, and you are able to drag and drop it to the scaffold definition. Unfortunately, the optical structure recognition is not perfect, but you can easily corrigate it by deleting the problematic part and adding and corrigating, for example, this misrecognized R group, because it's R6 in the document. If you check it, you can see here. We fix the scaffold. The next step, the extraction of the fragment definitions. Some of the fragment definitions is represented by letters in the scaffold. Epsilon y is related to this last fragment in the Markush tree, and you can find it here in the document. If you click on it, you can simply drag and drop it to the fragment definition. Epsilon Z, R group Z is not recognized correctly. This is not recognized in the document, but this is not a problem, because if you double click on the R group definition, you can draw it manually. very simple way. Yes, it's fine. If you want to link it back to the document, it's also possible by right-clicking to the fragment and say, I want to add a reference to the document. You can simply select now the corresponding part of the document and say OK. Thus you can see, if you select any of these fragments, the tool is scrolling automatically to the relevant part of the document. We can continue the extraction by the other fragment definitions, for example, R13. You can drag and drop it the same way. As you can see, there is some misrecognized attachment points here. You can fix it very easily by double-clicking on it and adding the attachment point to the missing attachment point to the fragments. I think all of them is correct, but we can check it, because if it's not correct, you can see a red dot here, but that all of the red dots has disappeared. As you can see, you are able to select all of the fragment definitions, copy them, and if you don't want to corrugate again in R3, you can copy-paste it, and this way you don't need to do again the attachment point adding part. The same way you are able to extract all of the other fragments, all of the other R group definition, for example R4, the same is R7, R5 and R6 are here. Let's drag and drop them. And some deeper level is also missing. R14 can be added the same way. Let's do the same with R17 and 19. And the only missing here is R18. We still have some errors. If you click on the checker view, the tool automatically scrolling the problematic part. We have some attachment errors. If you double click on the fragment, you can fix it. Let's do that. It's very easy. We still have a attachment error somewhere. I think it's very good. You don't need to go through the Markush and find the problematic part. If you click on the checker view, it's automatically scrolling the problematic part and you can fix it. Okay. Now only two fragment definition missing, R group definition missing, R1 and R2, but this is a little bit tricky in the document, because if you scroll up, you can see R1 and R2 join to form a 6-member substituted or unsubstituted ring. You can represent it in many ways. I will show one of the possibilities here. For example, you are able to select these two R group and you can create a bridge. This is R1 and R2 definition together, but this is useful if you have a separate definition for R1 and R2 and both together. In this special case, I suggest some other thing by read down a Markush a little bit and saying we have only one definition, and this is R1 plus R2 definition. Okay. This way, you need to draw only one definition, and you are able to add fragments manually to these definition. We can start something very simple. This is one possible fragment here. You can link it the same way back to the document by adding a reference. You are able to add a reference to the whole paragraph, not only the individual words. But this is not the full representation of the meaning of this text. You need to add some additional fragments. Some way can be to add some general definition by multiply this scaffold part. Okay. Saying it can be a single or double bond. I can do in better way. Yes, and it can be a nitro. Let's represent first the nitrogen possibility. But you can do the same with oxygen, nitrogen, and sulfur, or you can use a least atom here and so on. But for demo purpose, I think it's enough, and it's very easy to follow the same way. Now, currently we have a consistent Markush structure. This is not the absolutely correct representation yet, the original claim, but this is consistent. There is no big errors in this Markush. We can use it as a starting point of the extraction of the exemplified structures related to Markush. You can use it many ways. You can do it many ways. For example, scrolling down and finding the exemplified structure section, selecting one by one the examples and drag and drop it under the Markush, and the tool automatically validates it against the Markush. But as I mentioned previously, you have another option using the extraction wizard. The extraction wizard is a little bit different here, because if you go to the next page, you can see here automatically added the scaffold. I don't want to use the full scaffold. I remove some not so interesting parts, and I want to use only this one for this part for the extraction. Let's click on finish, and the tool automatically extracted all the structures from the document matching to your query. As you can see, most of them are not matching perfectly to the Markush structure, but some are matching. This is a good news. That means our extraction was not fully wrong. If you select the first one, the tool is scrolling to the relevant part, and you can see this is not an exemplified structure. This is from the description section, the state-of-the-art section of the document. I don't want to extract this structure. I remove it. The second one is the example 1. The next one is the example 2. And you can trust me, if you go through, all of the exemplified structure is extracted from the document. In the later section, we have some from this list. And after that, we have 2 structures from the cited document section. I don't want to use this cited document section. I can select both of them and remove it. And you can ask why not these structures extracted from the document. I can answer it really easily by change back to structure to text selection mode and selecting the first one. And if you try to find it in the document, you can see this is the same what you can find in example 2. That means the tool correctly extracted the first occurrence of the structure, but not extracted the second occurrence, because it can be a duplication. And you said in the extraction panel previously you want to filter out the duplicates. Okay. Let's go through to these exemplified structures. As you can see, and as I mentioned, some of them are highlighted by red and some of them are highlighted by green. Red means not matching perfectly to the Markush structure. Green means it's matching perfectly. I can close this Markush tree because it's easier to understand. you can see here the hierarchy. The green box are the matching R group definitions, and the red ones are the not matching R group definitions. As you can see, in the case of the first structure, this substituent, large black substituent, not matching to the Markush structure, only the green part. And the tool said this R group definition the problem. This R group definition clearly said it can be only an amine group and nothing else. That means your Markush structure is correct here. You don't need to modify anything. Simply, this exemplified structure is not claimed by the claimed Markush structure. You have the same in the case of some of these fragments, but this is that we can find some different cases here. For example, this exemplified structure is not matching because we have a heterocyclic substituent in the R5 position, and R5 not contains, according our definition, heterocyclic. But if you click on R5 and the tool scrolling to the relevant part, you can see the text contains the heterocyclic definition. This is not recognized correctly. You can do the manual adding process here again, add new fragment, and choose from a homology definition list the heteroaromatic alkyl group, polycyclic alkyl group. Okay. By adding this, you can find it's not red anymore, it's green. That means it's matching. We have some other similar examples. For example, that one. And as you can see, here is a heterocyclic ring with a substituent. Let's open and close it. And it says the problem again with R5, because R5 said the group can be a substituted or unsubstituted heterocyclic. Unfortunately, currently we have no feature to representing substituted or unsubstituted directly, but you can very easily do a workaround here by adding an additional R group. I call it R21. Oh, sorry. Yes. And adding a definition to this R group, something very general. For example, it can be a hydrogen. It can be any atom and any group. And a little trick, it can be any atom substituted with other two any atoms. Because the any group definition not contains some smaller molecular weight substituent. Okay, let's click on OK. And as you can see, this is not red anymore. It's matching, and the tool said it's matching by R5 heterocyclic substituted definition and the any atom definition of this newly added general definition. All other structures are really not matching. As you can see, here you have some problems related to the ring system. The R1 definition says it must be a 6-membered ring, but here, highlighted by black, you can see only a 5-membered ring system. We have another interesting example, that one. You can see here not only the fragments or the R groups are not matching, but also the original scaffold is not matching, but the tool highlights you the maximum common substructure based between the original scaffold and the exemplified structure, and you can see the same highlighted in the scaffold too. I think it can be a very good way to find the errors, inconsistencies, and check your extraction data. We called this functionality the non-hit highlighting. Okay, we have all the Markush structures extracted, and our Markush structure more or less is correct, I think. We can go to the exemplify structure list, and we can add some additional data if you want. If you click on any of these examples, the tool is scrolling to the relevant part, and you are able to add additional fields to this list. Let's add a list containing the information, the retention time values. Create, and retention time value, it's alone, it's meaningless, but related to liquid chromatography mass spectroscopy data, you need to ampere Z values related to this retention time, and you are able to add this one, Z, okay. In the later part of the development, we want to add some functionality to be able to extract this kind of data automatically. Currently, unfortunately, we can't do that, but you can do it very easily in most cases by simply select this information from the document and copy-paste it to the extracted data. And you can do the same in the case of all of the part. The tool can help you by scrolling to the relevant part of the document, and this way it's very hard to extract wrong information from the document. I don't want to do it for all of the exemplified structure. You can imagine it's possible in the same way for all the examples. It looks a little bit time-consuming, but it's not so much. In the case of this document, you can do it until 1 or 2 seconds. It's not a so big thing. After you finished the extraction process, you usually want to share the extracted result with your colleagues. ChemCurator offers many ways to do that. One and the most trivial way to extract the project by using the export project wizard, and you are able to export it to a zip file. But we can offer some more sophisticated way to share your project with your colleagues. We call it ChemCurator Integration Server. ChemCurator Integration Server, it's a web application capable to share the extracted project between ChemCurator users. ChemCurator users can upload the projects to the central in-house server, and other users capable to download this project, modify them, and upload it again if they want. Other users using drug discovery tools, for example, InstantJChem or Plexus Design or Plexus Connect, are able to connect to the central database and are able to do a comparison or a search against this database and using the extracted information in the drug discovery process. Some of these use cases can be, for example, the comparison of high throughput screening data against the extracted exemplified structures and Markush structures. But you are also able to run individual search against the extracted database. I want to show you how can you share this project. The first thing you need to do to set the integration server address, your in-house integration server address. It's different, obviously, by company. You need to set the server address and your username and password, and you are able to test the connection if you want. And if it's successful, you are able to share the project to the integration server. It's really easy. The only a small dialog shows you the project is successfully shared. And any other ChemCurator user be able to use the new project, download shared project dialog. And as you can see, the last added project, it's added yet. This is the project curated by me now. I'm able to download it, but I already have it. If you modify any of this project, you can see this is a small icon representing it's a shared project. And if you modify any of this project, for example, removing a structure from this list, you can see the icon changed a little bit and a small yellow triangle appears, and that means it's modified. And the menu is also changed, and you are able to upload the changes or download the changes from the server, or removing the shared behavior of this project if you want. That was what I want to show you today. How can you use ChemCurator in your daily work? I hope it was useful, and I'm waiting for your questions.